Your emergency backup talk is now going to commence. Before I start, I will admit that, so this is a talk that I gave at a Pythonista 5 years ago, and it was well received then. Hopefully most of you weren't there, so you haven't heard it already, but I didn't have slides for that because this was the first Pythonista that we did entirely online. It was during the start of COVID. So when I started putting together for this, I was like, oh, I want to do the slides kind of a different way, and I, for various reasons, decided it would be easiest to like just shove them into my website as pages, and I may have tried to create slides slightly too close to the sun, and so I didn't finish. So if we get to the end of the talk and the time, the slides kind of fizzle out, but we'll go through what we've got. So we're going to talk about context managers. And so 2025 is a big year for context managers. It's been a year about a lot of things. This is a really terrible 2025 word cloud that I got from 7 best word cloud generators in 2025. And if we zoom this image, you'll see why context managers are so important in 2025. It's the 20th anniversary of PEP 343. So that's the PEP that introduced context managers. We're going to talk about them. We're going to start with this topic that I'm sure is relevant to everyone, how not to crash your program by hitting the max number of open files. So I have a simple little program here. So I don't know about you all, but this is a problem I run into pretty much daily. So I wrote this little program, and I ran it, and what happens when you run this program, where's my cursor? See, too many open files. So annoying. So this is a trick. Over here, we're opening too many files. That's a little sort of joke there. So so what should we do about this? Like, how do we avoid this? The answer is use more context managers. Okay. So that's why we're talking about context managers today. So that was a contrived example. You mostly like probably you haven't run into this in practice, but it is possible to run into it accidentally. And so context managers were kind of designed to solve problems like this. And so this is kind of the classic example of like this is the sort of correct way we're taught to open a file. You say with open. And so what this does, the with keyword, we say with, and then there's a block of code beneath it, and then this guarantees that the file gets closed after that indented block of code finishes. We don't have to remember to do the close, and it also happens even if the code that's indented there, like something unexpected happens, like it throws an exception, the file still gets closed. This is a silly program because it reads itself and exits it, and it will hit the recursion limit. And that is a valid file name, not on Windows, but on Linux or Mac, so that's fun. So I guess I was going to ask, like, hands if you thought this. I'm a little confused about my heading there. Oh, right. There's code underneath here. Okay, so why are the context managers important? So look at this program. Do you think this program is going to work, or is it going to say too many open files and crash? So think about that for a sec. And the answer is that this program actually works fine. And it works fine because of garbage collection. So like this program, it opens a file, it reads it, it returns the string that was read in. And at that point, there's no longer any reference to the open file. So Python in the background is going to clean that up and close the file handle. And we will never hit the limit of too many open files. So that explains why this program doesn't hit the limit. And why most people, like in your everyday life, will not run into that type of bug. Like you do have to do some slightly unusual things to like accidentally do that, but it does happen. Given that it doesn't sort of it doesn't happen all the time. Like how important really is the with block? So like, do we really need it? Yes, and why? Like, I do want to know why. This slide doesn't know. You don't know. So I think the main reason is just this this level of safety. It makes it practically impossible for the code to do the wrong thing. So like I said, even if that code that's inside of the with block throws an exception, the file still gets closed. Also, this is just less code. Sorry, I don't have the example on screen that I wanted to. Do I have one on the, okay. The point is the with block lets you do the thing with even less code and there's less to screw up. So we're going to look at several examples of why the context managers are useful, but before we do that, I want to talk about like how they actually work under the hood. If you don't already know, you're probably really confused right now because I've been saying context managers a lot without explaining what they are. The best way to learn is to go in the Python docs to the glossary, context managers, and you look this up, and I'm going to have to zoom that in. Yep. And it scrolled. I should have zoomed this ahead of time, I'm sorry. So the Python docs will tell you that context manager is an object which implements the context management protocol and controls the environment seen in a with statement, see PEP 343. And then you look right above that and it tells you that the context management protocol just means enter and exit methods. And also tells you to go read the PEP to like understand more about it. So this is the technical definition. If you have an object and you implement enter and exit, then you have a context manager. And it's something that can be used in the with statement. If you follow the docs here by clicking on with, then you get to this section of the docs that's fairly technical. This is inside of the language reference part of the docs. And it talks about the syntax. But then here it talks about, this is like the exact process that happens when you use with. And so just to summarize, basically you're going to say with and something. That expression there is going to be evaluated. And it should produce a context manager, which is an object with enter and exit. Python is then going to basically save that object's enter and exit methods so that it can call them later, and then so that it can like upfront fail if you gave it an object that doesn't have those. And then Python is going to call that enter method. If that enter method returns something, that's going to be assigned to whatever name you had after as. So you have with something, as, and then a name. So that's going to be assigned the result of the enter method. Then all the code that's indented in the with block, which here is called, let me scroll down. Here they call it the suite. The suite, that's all the indented code. That gets executed. And it might finish or it might throw an exception. And after that, the exit method is called. And if an exception was thrown, then the exit method is going to have passed to it all the information about the exception. And it's possible for the exit method to return something that says, actually, suppress that exception, please. Or by default, it won't suppress it. The exception will bubble up. So that's the technical version. We're going to go back to this. Oh, nope. I just closed them. Sorry. I got to click through a couple things again. Okay, we're back. So this is my high-level summary. Summary of all the technical stuff. You put your context manager expression in the with block. You have some code, and the enter and exit methods get called above and below that automatically for you. And just a side-by-side comparison, the top is the code you would have to write to do this by hand, and the bottom is the code you get to write with with statement and the context manager, and you can see it's just quite a bit nicer, saves you some typing, saves you from forgetting to do the finally, things like that. Okay, so we're going to look at some examples. So first example here, this is, we're calling a function. In this case, we're calling the help function. It prints text to standard out. It's not configurable, it just prints text to standard out. It doesn't return something. But in this case, we don't want the text to go to standard out. We want to capture the text into a string so that we can email it to everybody who signs up for my low effort Python tips newsletter that I'm starting. That was a joke, but talk to me afterwards if you're interested. So in this code, we temporarily are replacing sys.standardout with a string IO object so that when the help object writes the standard out, we get it in a string IO. And we're being careful to like restore back to the previous value when we're done. So there's a context manager for that. This is actually in the standard library. There's a context manager called redirect standard out. It's in context lib module, which we are going to talk more about later. But there's a way to do that. Another example is locks. You see this, like most locking libraries will support this, so you can do the bottom one instead of the top one, which ensures that you can't accidentally like forget to release the lock. Okay, so some simple examples there, and we're moving on. So earlier, I explained the context managers as kind of, they can help you not forget to do these cleanup and teardown operations. That I feel like is how they get used most of the time. But there's a slightly sort of more general way that I like to think about them, which is I think about context managers as like functions, but twice as cool. And I'm going to explain that. So functions are useful because they let you sort of factor out a chunk of code, give it a name, and then use that name instead of like having to copy paste that code all over the place, right? I did not make new graphics for this. I took a screenshot of the time I gave this talk a while ago because I don't know, I lost all the graphics about this. This is a graphical illustration of, look, the function lets you pull out that block of code and give it a name, right? So context managers, you can think about them similarly, but instead of pulling out one block of code, they let you pull out 2 blocks of code and give it a name. So that's why, you know, twice as cool, right? So maybe I'm overselling it a little bit because it's not, it doesn't let you pull out any 2 blocks of code. It's like, you know, they're related. They're like a setup and a teardown kind of thing. And it has to be a scenario where they sort of surround something else, but it lets you like pull out this sort of surrounding thing and put it in the context manager. So we're going to look at, here's that same example from before where we're redirecting standard out, and I've just highlighted like all of these lines that are in the sort of magenta color. Those are the things that are being pulled out into that context manager and then letting you use it with just one line. So more readable, you can't mess it up, and it's less to type. So there's a bunch of other potential things that context managers are useful for, they get used for. So for managing database connections and transactions, you'll see code similar to this, like the with block there is managing the whole database transaction. Usually like the way these are done is if the code in there threw an exception, then the transaction would be automatically rolled back instead of committed. They're used for patching things for unit tests. You've probably seen that. You could use this to time how long code takes. I can't remember if there's a thing like this in standard library or not. But interesting thing to note in this example is that, so you say with time function as timer, right? And that assigns something to the name timer, and then you can still access that after the with block, which is, sometimes people find that unexpected. And we'll talk about that a little bit more later. Final example I've got here is there's a cool alternate async framework called Trio, which I've used for a couple projects, and kind of enjoyed it. But they have this interesting way if you're going to run several tasks concurrently. They use the with block with this thing called nurseries, and it will like wait for all the tasks to complete before the with block sort of exits. So you can kind of like just set all your things up in a clean way, and then it automatically waits for them. Okay, so now we're going to talk about how you actually create a context manager. So the first option is that you write a class with enter and exit methods. And I have not even provided an example of that because the second way is so much better. So the second way you do it is you you import this context manager decorator from contextlib. And then you just write a normal function. It's not quite a normal function. It uses yield. So it's technically a generator function, but pretty much a normal function. And the point where you put the yield, so everything above that is like the setup. When you put the yield, that's where the code that's indented under the with block would run. And then after that, you have your cleanup. And that context manager decorator takes this and it sort of automatically turns it into the enter and exit methods that are needed. This one's a little simpler to look at, but usually you want to also think about what if the code that's running in the with block throws an exception and you want to handle that. So usually you want to do this. You want to do try finally around the yield in most cases. And you might remember I mentioned you can say with context manager as and then a name. If you want something to be assigned to that name, you can yield it here. So if you yield a value, then that's what gets assigned to the name. Okay, so I'm going to start to sort of wrap up here by talking about there's sort of two different aspects of context managers that are kind of important or that sometimes cause confusion. And so the first one, I alluded to this before, but there's this interesting thing with scope, and that people, especially like newer Python programmers that are maybe more used to a different language, might assume that there is a new scope inside the with block, and that things like defined in the with block won't like survive outside of it, but that's not the case. Python only does scopes at like class level and function level, I think. In any case, the with block does not have a new scope at all. So any name that you define inside the with block will still be defined outside of it, in the same function. And so, I mean, obviously you see that in this simple example where you're reading a file, but also it's useful in cases like this where you want your context manager to like return something that you're then going to look at later. So this is a theoretical timer context manager that will just check how long the code took to run, and then it just gives you this object that lets you access the number of seconds afterwards. So you can see like that name t being assigned, and then it's still available later. And I just have to point out that this code has a subtle grammatical bug, which is that it would say 1 second, and I would appreciate if you write code that says 1 second. It's only one extra line. I mean, I didn't write it, so I guess I shouldn't be complaining, but now a magic trick. This is the same slide because I didn't write the last slide because I ran out of time. So I may try to put the code up for this last one. Yeah. I think I'm a little ahead of schedule, so give me just a moment while I try to... Oh. Keyboard shortcuts aren't doing what I think they should be doing. What did I call it? I'm just gonna... You can see behind the curtains as I pull up my script. so that we can jump to the bottom and I can show you. This example, but I don't want to distract you with all this text, so let me. Okay, how's this for a kind of unpolished presentation skills? So this is an example we saw before with redirect standard out. So what I want to talk about here is global state, because this comes up with this type of context manager. If you have experience in a code base with many things going on at the same time, like you're using async, or and you might have different things kind of happening concurrently, then you might have sort of alarm bells with something like this, like, oh no, I need to worry about, like, what if one of my async functions tries to redirect standard out and the other one like doesn't need it and stuff, right? Because standard out is kind of like this global thing. So that you're modifying to make this work. So how do you get around that? We have good ways to get around it. The implementation of this, you might remember, it just reassigns sys.standardout to something else, and then it sets it back later. Like, that's what redirect standard out does. And so like that is a global thing, and we can't change that. But what we can do is use something called contextvars. I'm going to skip down. Skip. Still skipping. Okay. Oh, let me explain this example real quick. So I have a context manager here. This line. Context manager called log prefix, and what it does is you give it a string, and then every log message that is logged from inside of that with block gets that prefix attached to it. This is and this works like it doesn't have to be your code that's running the with block. Any code that uses the standard logging framework, this works. And so the question is, like, how does this work, and how is it compatible with potentially async tasks running concurrently? And so the answer is we're using contextvars. And so here's the example. This is the actual implementation of this. So we import contextvar. You'll see in the code here, we set this contextvar. So we've declared a contextvar that's the current log prefix. Here we set it. We do this usual context manager try, yield, finally thing that you've seen several times now. And at the end, we say reset. So what the contextvar is giving us here is it's sort of like a global state, but it's actually hooked into async IO. It's hooked into the async framework. And so it keeps track of the different like ways that you've called into it. And if async IO goes, okay, we're suspending this task and gonna run this other task, then it sort of talks with the contextvars module, and it like swaps out and goes, okay, like for this async task, the var was set to this. So basically, it solves this problem of you have something that would be global state, but you need to change it from different things that might be running concurrently. This module, contextvars module, has the documentation is pretty straightforward and easy to read. Make sure I didn't miss anything important I was going to say. Yeah, basically. Just look at the documentation. It's a good thing to know. It can be very useful. And I've talked to some people who are a little bit worried about like overuse of this, because anything that resembles global state can seem kind of scary sometimes. My experience with this has been that it seems pretty pretty isolated if you use it in this pattern where you declare the context var, and then the only thing that accesses the context var is right there in the same module. Nobody else needs to know that this exists. It's pretty isolated right here, and it works very well. And so I don't really have a nice conclusion slide or anything. I mean, you saw that I ran out of slides. But I hope that you learned something interesting, and that you are, tell all your friends that it's the 20th anniversary of PEP 343. Okay, thank you. Yeah, we have time for a quick question if anybody has one.
A quick one is, where is token coming from in line 391?
Yeah, it comes from that set call. I don't.
Oh, sorry.
Yeah, I don't understand exactly the like inner workings of contextvar, but it's something that it uses to keep track of like which async task you're in.
Thank you.